All right, my lovelies, for those of you that would like to rewatch, or if you've missed class, we're going to talk about 9.1a, exponential graphing. So our first ICAN is I can graph an exponential function. What in the heck is that? An exponential function is a function with an exponent. So if you see, let's say, exponent as a variable, maybe that'll make more sense. So x would be our exponent. Say, here's our function here. A times b raised to the x power. That's what we're going to be looking at if it's raised to a variable power. We're going to identify asymptotes, domain, range, and exponential functions, and then we're going to identify if a graph is a growth or a decay. Really quick, I want to talk about what is an asymptote again. We talked about this in conics, but I want to review it. An asymptote is a line that the function will never pass. Kind of like a do not pass go. It's an asymptote that the function will never pass that line. It'll approach it, it'll get really, really, really close to it, but it will never pass it. So we're going to identify those asymptotes. So our first example here is exponential growth. This graph is getting bigger and bigger and bigger and bigger and bigger. You notice that the absolute value of b is greater than 1. That's exponential growth. Lots of times we talk about viruses with this. A perfect example this year would be COVID-19. That would be an example of exponential growth. Exponential decay is absolute value of b is less than 1. So this is actually going to be a fraction. So if you have a fraction, it's going to be decay. It's getting smaller and smaller and smaller. A fantastic example of that is a car depreciation. So as soon as you drive that brand new car off the lot, you start losing money at an exponential rate, which means a very quick rate. A, again, is a vertical stretch or shrink, just like we've been doing this whole year. And then it does tell you down here again what an asymptote is. One more thing I want to mention, if A is negative, that doesn't mean it's going to be a decay. It means that it will be reflected over the x-axis. Again, we're going to have our h and our k's, but I'll show you the only importance of our h and our k, so don't let that scare you. We're going to be using the exact same process for all of these. The h and the k we only care about for our shift, and then we're going to throw them away. We don't care about them. So how are we going to do these guys? I've got 2. 2 is my base. So that's my b right here. I don't have an a, so it's like an implied 1. This section is going to be our ay, just like we've done in the past. And here's the super easy part, is for our x's, we're always going to use the same values. -2, -1, 0, 1, 2. Don't have to worry about coming up with numbers. Those are always going to be your values. And what that is going to get plugged into is our exponent right here. So we're going to take our base for each one of these. Our f of x is our base. So we're going to start with 2, and we're going to raise it to the x, which in this case is a -2. Now remember, anything raised to a negative exponent, we have to flip upside down. So this is actually 1 over 2 to the positive 2, which is going to give me 1/4. So when I plug in a -2 for my exponent, I get a 1/4 out. And we can continue on down the line. I've got 2 to the -1. Again, negative exponent, so let's flip it upside down. 2 to the first power is just 2, so for this one I get 1/2. Important thing that we always need to keep in mind is anything raised to the 0 power is going to be 1. And then I have 2 to the first power, so just 2. And then I have 2 squared, so I end up getting 4. Typically, we would multiply all of these by our A to get this column, but our A is a 1, so this column is going to be the exact same as what we wrote in. 1/4, 1/2, 1, 2, 4. And then we can cross that guy off. So our shift, if you notice here, HK, we do not have an HK. So this is like a +0 and a +0. Our HK is 0, 0. This one is going to be an origin of 0, 0. So I can draw these lines in because one of those is going to be my asymptote, and I'll show you which one in a second. Since I've got a b greater than 1, this guy is a growth because b is equal to 2. Now let's graph these guys and see what our domain and range and asymptote are. So from my 0, 0, I am going to start by going to the left 2 and up 1/4. Let's use a different color. I'm going to the left 2, so -2 and up 1/4, roughly here. Then I've got -1, and I'm going up 1/2. You can see it's starting by growing slowly, but check out what happens. I've got 0, 1. We're getting bigger. Then I've got 1, 2. Oh, it's getting really big. And 2, 4. So you can see it starts by kind of getting bigger slowly, and then it goes bigger really fast. So since we said that is a growth, it went up. And if we look left and right, our x's can be anything. It looks like our x's are never going to get bigger than around this area, but if we keep going up and up and up and up and up, our x's can be anything. So x is an element of all real numbers. Now check this out. Our range, our y's, we don't have any y's down here below 0. So our y's have to be greater than 0. They're never going to touch 0, so they won't be equal to 0, but they will approach as close as they can to get to 0. So y has to be greater than 0. And then remember, my asymptote is a line. Here was my asymptote. It's never going to cross that line. So my y is equal to 0 in this case. And if you want to think about it like this, your y will always be equal to whatever your k is. And our k was 0 in this case. So let's try another one. Okay, this one is kind of fun because this is negative, so it's going to be reflected. We'll see what happens when that happens. However, our b is still greater than 1, so this is still going to be a growth. I don't have an h, I don't have a k, so my shift is still going to be at 0, 0. I'm going to plot that guy, and that's going to end up being my asymptote. So this is where I am going to be shifting from for all of my points. Remember, I've got -2, -1, 0, 1, 2. Now let's see what happens. We can disregard this for now because that's going to end up going in when we do this. So our base is 2. We're going to use 2 for all of these. We're raising 2 to the -2. Remember, we've got to flip that. So I've got 1/2 squared. So I end up with 1/4 again. So these are all going to look similar to this because we have the exact same number. So 2 to the -1, I've got to flip. And I get 1/2. Anything raised to the 0 power is 1. 2 to the first is going to give me 2, and 2 squared is going to give me 4. Now, I've got to multiply everything by -2 because that is my a. Maybe we should write that down. A equals -2. So I'm multiplying everything by -2. Now we have to remember, fraction times a whole number. I got 1/4 times -2 over an implied 1. I can reduce to 1. I get a -1/2 when I plug that guy in. So I get -1/2. Now I've got a -2 over a +2. I get a -1. -2 times +1, I get a -2. -2 times 2, I get a -4. And -2 times 4, I get a -8. Let's cross those guys out and see what our graph looks like. Remember, I'm only using this and this to shift from my 0, 0. So I'm going to go to the left 2 and down 1/2 because that's negative. Left 2, down 1/2. Left 1, down 1. Growing slowly or getting smaller slowly, but still growing. And then 0, -2. 1, 4. Starting to become exponential. And 2, 8. I think that's right about there. So again, we're going to be approaching that line, but we will never cross it. So our domain is going to go on and on and on to the left and on and on and on to the right. So x is still an element of all reals. This time our y's, our range, they cannot be greater than 0. There's no y's up there. So y has to be less than 0. It's never going to equal 0, but it will approach 0 very, very closely, but it's not going to cross that line. Therefore, our asymptote is y equals 0 again. And that is what our graph looks like. Let's do a couple more examples. Because this time, oh, it looks like we have a k. This is still -0, so I don't have an h. My h is 0, my k is 2. So I've got 0, 2 is going to be my shift. My base, my b is 1/2. Remember what we said when it's less than 1? This is going to be a decay because b is less than 1. It's 1/2. I do not have an a, so it's an implied 1. Now let's see what happens. Remember, you don't have to think about this part. We're always going to be plugging in -2, -1, 0, 1, 2. And let's see what happens. Our base is 1/2, and we're going to raise that to the -2 power. We're just plugging that in for x. Since it's raised to the negative power, we've got to flipperoo these guys. So I get 2 squared. I end up with a 4. And then I've got 1/2 to the -1. Again, flipping that guy 2 to the first. I end up with 2. Anything raised to the 0 power is going to be 1. And then I get 1/2 raised to the +1. So this guy's going to be 1/2. And 1/2 raised to the +2. So I get 1/4. So hopefully you can see with the decay, these numbers are getting smaller, 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 smaller. With our growth, we got bigger, 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 bigger. So hopefully you notice a pattern there. Since my a is 1, I can just simply copy these numbers straight over because nothing is changing. Oops, that should be a 4. Sorry, 1/4. And our shift was 0, 2. So let's plot that. That is going to be where I am going to plot all my points from. Okay, so let's see what happens. I'm going to get rid of those. And from my point 0, 2, my new origin, I'm going to go to the left 2 and up 4. Then I'm going to go to the left 1 and up 2. And then I've got 0, 1. And 1, 1/2. Oh, we're starting to even out here. And 2, 1/4. So as you can see, we're getting smaller and smaller and smaller for our y's. We're going to approach that asymptote, but we're never going to cross it. So let's see what happens. Again, hopefully you can see my y's can go on to the left and on to the right forever and ever and ever. So x is still an element of all real numbers. Now check it out. I don't have any y's down here, but is this time, is it 0? No way, man. This line is y equals 2. Again, that's my k. So my y's have to be greater than, they're up here. So my y's have to be greater than 2, which makes my asymptote y equals 2. And I'm done. If you've had enough, you think you get it, you can go ahead and stop, but we're going to do some examples of different shifts with hk. So this time I have an h of 3 plus 0 would be my k. So my shift is going to be 3, 0. I'm going to copy that down right off the bat so I don't forget. I've got my b is equal to 1/3, which is less than 1. So this is going to be another decay since b is 1/3. That's my base. That's the number I'm going to be using. And then I've got an a of 2. So that's what I'm going to plug in when I multiply. Don't have to think about this one. I've got -2, -1, 0, 1, 2. And I'm going to be using 1/3 as my base. So now that we've got all of this fun stuff, we can get rid of this and this. All I care about is raising this to my power. So first let's plot 3, 0. So that's where I'm going to be shifting from. 3, 0. And it's a decay, so it should get smaller and smaller and smaller. Let's see what happens. So I'm going to start with 1/3 raised to the -2. Remember, I've got to flip these guys. So I get 3 squared, which is going to give me 9. And I've got 1/3 to the -1. Again, negative power. I've got to flip. 3 to the first power is going to give me 3. Anything raised to the 0 power, I'm going to get 1. And then I get 1/3 raised to the first power. So I get 1/3. Notice again, smaller, 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 smaller. And I have 1/3 squared. So I end up with 1/9. Now this time I've got to multiply everything by 2. So I'm going to multiply 2, 2, 2, 2, 2. Once I do that, I can cross this column out. So 9 times 2, I get an 18. 3 times 2, I get a 6. 2 times 1, I get a 2. 2 times 1/3, careful with this, I get a 2/3. And 1/2 times 2, those 2's will reduce, so I end up with a 1. Is that right? What did I do wrong here? Oh, that's what I did wrong here. Sorry, my bad, my bad, my bad. I knew that that wasn't right because I have to keep getting smaller, and 1 is not smaller than 2/3. So I have 1/3 raised to the second power, so I actually end up with 1/9. My bad. And if I square, or I double 1/9, I end up with 2/9. Sorry about that. So I'm going to be starting at my green dot, well now my purple dot, and I'm going to cross this off. I'm going to go to the left 2 and up 18, which is going to be way off our chart. I'll just put it up here somewhere. Then I'm going to go -1 and up 6, roughly here. 0 and up 1. 1 and up 2/3. You can see it's leveling off. And 2 and 2/9. There we go. Now we can draw our graph in. We're never going to cross that green line, but as you can see, my x's can keep going left and right forever and ever and ever. So x is still an element of all, of all reals. Now my y's this time, I have no y's below 0. So my y's have to be greater than 0. They're never going to equal 0, but they will be greater than 0, which makes my asymptote y equals 0. That green line is my asymptote, which works perfectly because my k was 0, and that's exactly what we wanted here. Couple more examples, and then we'll move on to the next section in a different video. Okay, this time we have an h and a k. So remember our formula was a times b to the x minus h. Since I've got an x minus h, and this is plus, my k, or my h is going to be a -1. It's opposite of my h, but my k is face value, so my k is -3. And then we can get rid of that fun stuff. So I'm going to plot -1, -3. And that's going to be an asymptote. That is my starting off point when I plot these. My b is 1/3. It's smaller than 1, so it's another decay. b equals 1/3. We just said our shift was -1, -3, so we're good to go there. And the last thing I need to do is get some numbers. Without thinking, I'm just going to plug in my regular number. Oops, I did those backwards. -2, -1, 0, 1, 2. And we can plug those in for x and see what happens. So I'm going to use 1/3 as my base, and I'm going to raise that to the -2 power. Notice it's negative. I've got to flipperoo those around. So 3 squared, I end up with 9. I'm going to do the same thing. 1/3 to the -1. I'm going to flipperoo those around. So I get 3. Anything raised to the 0 power is 1. And then I have 1/3 raised to the first power. So I do get 1/3. A decay. I'm getting smaller and smaller and smaller. Fantastic. Exactly what we wanted. So 1/3 squared, I would end up with 1/9. These numbers should start looking familiar to you depending on what our base is. So now I've got a -2. I need to multiply everything by -2, -2, -2, -2, -2, which actually, oh, the last one was +2, so it'll be a little bit different for this one. So I've got ay, I end up with 18, -18, -6, -2, -2/3, and -2/9. Let's see if I did that right. I'm going to cross through those guys off, and now I am starting at my blue dot. So I'm going to go to the left 2. Let's do green. I'm going to go to the left 2 and down 18, which is way off my graph. I'm going to go to the left 1 and down 6. 1, 2, 3, 4, 5, 6. 0, 1. Oh, and we can notice this is going to flatten off nicely, just like we want. Then I'm going to go +1 and down 2/3, and +2 down 2/9. So my graph will look something like that. Again, my domain can go anywhere, left and right, so x is an element of all reals. And I happen to notice that I do not have any y's above that line, which happens to be y equals -3. So my y has to be smaller than -3 in this case, because all of my y's are below that line, which makes my asymptote y equals -3. And we're done. Yep. Okay, one more example. Bear with me. If you want to try this one on your own, come back, check your answers. Wonderful. So I've got an h, it's a minus, so we're going to take that 2 for face value, and I've got a k, so my hk is going to be +2, +1. That is my shift. My base is equal to 3, which is greater than 1. So this is a growth because b equals 3. It's going to get bigger and bigger, 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 bigger. Okay, now we can plug this in and see what happens. So I'm going to use -2, -1, 0, 1, 2. And my base is 3, so that is my starting off point for all these guys. I've got 3 to the -2. I need to flip that guy around. So I get 1/3 squared. I end up with 1/9. And then if I raise that to the -1, I'm going to flip it. And that's 1/3. Anything to the 0 power is 1. Then I have 3 to the first, so I get 3. And 3 squared, so I get 9. We said this was a growth. Our f of x is getting bigger and bigger and bigger. Fantastic. That's exactly what we wanted. Now we need to multiply by our a equals 2. So I'm going to multiply 2, 2, 2, 2, and 2. So my ay becomes my new point. So I got 1/9 times 2. I end up with 2/9. 1/3 times 2, I get 2/3. 1 times 2, I get 2. 3 times 2, I get 6. And 9 times 2, I get 18. Oh, and we didn't plot our shift. I apologize for my son. He's clearly a little bit nutso. So I got 2 up 1. And that's going to be my asymptote. Silas, stop. Okay, let's cross that guy off and see what's going on. So starting at my green dot, I'm going to go to the left 2 and up 2/9. So just up a little bit. I'm going to go to the left 1 and up 2/3. So just up a little bit more. 0, 1. 1, 6. So I'm going to go the right 1 and up 6. Now we're starting to grow a little bit faster. And 2, 18, which is off my graph, so I'm not even going to plot that guy. So again, approaching my asymptote, but never crossing it. My x's are going all the way left, all the way right. There's no restrictions there, so x is an element of all reals. My range, I notice I've got nothing below that green line, so my y's have to be greater than +1, which was my k, so that's fantastic, which makes my asymptote y equals k, which is 1. So my asymptote is y equals 1. And that, my friends, is how we graph exponential functions. In the next lesson, we're going to talk about writing these exponential functions. So stay tuned.